So here we are. Verify the identity by transforming the left-hand side into the right-hand side. Start off with the problem. Secant squared 3 theta times cosecant squared 3 theta equals secant squared 3 theta plus cosecant squared 3 theta. Remember, we're going to be transforming the left side into the right side. So I've highlighted the right-hand side because the right-hand side will not change. We'll prove that the left side is equivalent. So the first thing I did here, I'm starting to just take a look at what I have here, and I decided that I was going to try to create one fraction here. So I decided I would take the reciprocal identity of secant squared 3 theta from the fundamental identities, and that reciprocal identity is 1 over cosine squared 3 theta times cosecant squared 3 theta. That's the same as this, and again did nothing to the right hand side. I looked over here on the right hand side. I realized there are two terms here. So I'm trying to figure, well, how am I going to get two terms out of this thing on the left hand side? So what I realized was that cosecant squared 3 theta has a Pythagorean identity of 1 plus cotan squared 3 theta. That is to say that cosecant squared 3 theta is 1 plus cotan squared 3 theta. It's the third of the Pythagorean identities, I believe. Again, did nothing to the right hand side. So where that takes us to is here. I went ahead and did this multiplication. 1 times this is this, right? So we have 1 plus cotan squared 3 theta. 1 times 1 cotan squared 3 theta is 1 plus cotan squared 3 theta over cosecant squared 3 theta. Then what I decided to do is look at it kind of this way, if you don't mind. Look at it this way. That we have this fraction. We have 1 over cosine squared 3 theta, but equivalently we also have this piece over here. So I broke it. I partitioned it into its two pieces. This piece, 1 over cosine squared 3 theta, is this 1 over cosine squared 3 theta. This plus sign right here is this plus sign right here. And then I decided to trade in my cotan squared 3 theta using the cotan identity here. So if you look at your cotan identities, cotangent is equal to cosine over sine. So cotan squared 3 theta is equal to cosine squared 3 theta over sine squared 3 theta. Again, using an identity. This kind of looks like a mess, but it's about to clean up really, really nicely. If you look at this carefully, we have a fraction over a fraction, otherwise known as a complex fraction. That is to say that AB over CD is equal to AB times DC. So that's what I'm going to do here as we keep moving. Whoa. As we keep moving here. So that's what I did. This is the AB part, so I brought it down just so it was. I took the reciprocal of the bottom, and that's this turning into this. So I brought this up. This one is this one. This cosine squared 3 theta is this cosine squared 3 theta. I multiply them, but look, we have cosine squared 3 theta here. Cosine squared 3 theta here. They simplify to 1. Now we have 1 over sine squared 3 theta. Well, 1 over sine squared 3 theta is 1 over sine squared 3 theta. This piece right here, I just brought it down. So this piece here came from here. Brought this down. After I cleaned all this up, did my little bit of algebra and a little bit of arithmetic here, it simplified out to this. Well, if we look at this carefully, what is 1 over cosine of theta? It's secant of theta, right? And so I'm comparing this piece to this piece, and they match. And now I'm looking at cosine squared 3 theta. Well, isn't cosine squared 3 theta its reciprocal identity? Isn't it 1 over sine squared 3 theta? Yes, it is. So we actually have proven this we've proven it by the reciprocal identities. I think if you're having any trouble right now, the trouble probably centers around, are you aware, have you memorized your identities? If you haven't, please go back to the first video that I did where I actually outlined those things. And pause that video. They're all typed out. Pause that video, copy the things down, and then come back to this, and I think you'll really be able to do it. So good luck, and I hope it was really helpful.